Hello everyone. Today we are going to study about permittivity and relative permittivity. So as we are already aware about the Coulomb's law, and there was a term called permittivity denoted by K. We are going to study in detail about it. And I would request you all, before getting into this lecture, try and revise the previous lecture on the link below. Again, if I consider two charges q1 and q2, both positive in nature, and they are certain distance apart, we name it as r. So now with Coulomb's law, you already know the formula for Coulomb's law is F is equal to kq by r square. So basically it is not q, it has to be q1, product of q1 and q2, and even if the charges are same, it becomes q1 q square upon r square. So here there's a mistake, you need to correct it out, kq by kq1 q2 by r square, where k is the permittivity of the medium. You know that permittivity is a material constant. If the charges are placed in any medium, it depends on that medium. The formula for k is 1 upon 4 pi epsilon. Remember, that is not e, it is epsilon. So I've done the correction over here. Now, what exactly the permittivity means? So, with as of the name itself, we can see permittivity. It means something positive. It is some allowing something to flow on, to pass on. But basically, it is exactly the reverse of it. So, kind of, it sounds positive, but it works as negative. And what exactly it is? It allows the own medium to restrict the force between the two charges. Suppose if the two charges are placed in air, now there is a force of attraction or repulsion between the two charges. Now those two charges, the medium, that is air, will try and restrict the force between the two charges. And that property of the medium of restricting the force between the two charges is called permittivity. So it is actually allowing, it is actually permitting its own medium to restrict the motion, or you can say, the restrict the force between the two charged particles. And now you know that if the value of epsilon increases, now if you see the epsilon value increases, the force will decrease between the two charged particles. Now if we consider in free space, or in air, or in vacuum, so as I said earlier, free space and vacuum are very much, you can say, similar to air, but those are not exactly the same. So the concept remains same. If the epsilon increases or it is maximum, the force will be minimum. And remember that whenever we talk about free space or air, we don't write it as epsilon, we write it as epsilon naught. There will be zero in subscript. So if we say air, the epsilon will be, by default it will be epsilon naught. So the value of epsilon naught is fixed, that is 8.15 multiplied by 10 raised to minus 12 coulomb square per newton meter square. Again, if I say the epsilon naught value is minimum, the force will be maximum. It's vice versa according to the statement written above. So for air it is 8.15, which is maximum as compared to that of water. You can see for water it is 7.12. Sorry, there will be the value for epsilon will be lesser is compared to air, because it is 10 raised to power minus 10, and for air it is minus 12. So epsilon for water is greater as compared to that of air, and the force will be minimum. So if I say epsilon for any medium, rather than writing water, epsilon for any medium will definitely be greater than epsilon of air, that is free space, that is epsilon naught. And the force will for any medium will be lesser for force in air. So with that we conclude a relation for a relative permittivity. This is a new term for you, this is relative permittivity. So relative permittivity is given by epsilon subscript r, which is equal to epsilon m upon epsilon naught, that is the epsilon for medium upon epsilon in air. Now this is a numerical where we have two charges placed in air. You can see the above diagram having a distance d, the charge are q1 and q2 placed in air. The force will be F naught. Since it is air, the force will be F naught. It will be 1 upon 4 pi epsilon naught, that is k, q square upon d square. As I said, the charges are same. Whereas the same charges will be placed in liquid having the same distance d, Fm, where f is medium, so it becomes 4 times, it will be 1 f by 4 of the value of the air. So you can see the rest of the relation. We took the relative permittivity and substituting the values, we get epsilon as 4. Now again, second case where we again have two charges with placed at a distance of d in the medium of air. The force will be given as F naught since it is in air, and the value will be 1 upon 4 pi epsilon naught because it is in air again, q square upon d square. I'm writing it as q square considering the fact that the charges are same. And if I consider the same two charges placed at a half of the distance as compared originally, and in the oil, the medium is changed now and it is in the oil. So now I'm writing it as Fm, since I'm not writing it as F oil because it might not be suitable for us in this case, because F naught we write it for air. So right here we are writing it as Fm, that is medium, and the force becomes half, and it will be 1 upon 4 pi epsilon m since it is medium, q square upon d square. So you can see the force in air and forces in the medium has got some relation when we try and find out the relative permittivity. So now what we are doing is we are taking the ratio of both of them, and you already know that epsilon m upon epsilon naught will be equal to force in air upon force in medium because they are inversely proportional. Now what I'm doing is I'm substituting the values of F naught and Fm from the above two equation, that is 1 upon 4 pi epsilon naught q square upon d square for F naught, whereas for Fm it is 1 upon 4 pi epsilon naught q square upon d by 2 the whole square, because the distance between the two charges is d by 2. So I can strike out 1 upon 4 pi epsilon naught and 1 upon 4 pi and 1 upon 4 pi from numerator and denominator. So if you see, the left out will be f naught upon fm is equal to em upon e naught into 1 by 4, because in the above equation we didn't strike out e naught upon em. So here the left out, again what I'm doing is I'm substituting the values for f naught and fm, where f naught is exactly equal to f, you can see in the above equation, where fm is f upon 2. So here in this case, on the left hand side the left out will be 2, and on the other side it becomes e epsilon r, which is permittivity, em upon er, and we get epsilon relative permittivity as 8. Thank you.